The Internet has become the primary fabric for interconnecting the world. In today's class, we introduce the TCP/IP network architecture as well as routing examples. The architecture consists of 4 layers. The application layer provides services that can be used by applications such as HTTP web browsing, email, DNS, real-time transfer, and more. The transport layer provides 2 protocols on top of IP to enable process-to-process communications. TCP provides reliable stream service, and UDP provides best effort user datagram service. Application layer protocols such as HTTP and SMTP operate over TCP. Application layer protocols such as DNS and RTP operate over UDP. Both TCP and UDP operate over IP, the Internet Routing Protocol, that provides best effort connectionless packet transfer. All higher layer protocols access the network interface through IP. This feature provides the capability to operate over multiple different networks. IP layer handles the transfer of information across multiple networks through the use of routers. It provides a single service, best effort, connectionless packet transfer. It provides no mechanism for error recovery or flow control. Each host in the Internet is identified by a globally unique IP address. Strictly speaking, the IP address identifies the host's Internet interface rather than the host itself. A router is attached to 2 or more physical networks, with each network interface assigned to a unique IP address. For scalability, Internet addresses are hierarchical, consisting of network ID and host ID within a network. IP packets are routed according to the network ID. On a LAN, the network interface card is identified by a physical address. The network uses its own address to transfer packets or frames to the appropriate destination. IP address needs to be resolved to physical address at each IP network interface by Address Resolution Protocol called ARP. Ethernet uses 48-bit addresses. Each network interface card has globally unique physical MAC address. Let's consider a routing example as shown in the figure. We assume the Ethernet has network ID 1 and the point-to-point link has a net ID 2. In the Ethernet, we suppose the server has IP address 1 and 1, and the workstation has IP address 1, 2. The routing as IP address 1, 3. In the point-to-point link, the PC has IP address 2, 2, and the router has address 2, 1. The router, server, and workstations have physical address designated by R, S, and W, respectively. Let's consider a case that a workstation wants to send an IP packet to the server. The IP packet has workstation S IP address and the server IP address in the IP packet header. The IP entity in the workstation looks at its routing table and finds that the server is directly connected to the same network with physical address S. The IP packet is thus encapsulated in Ethernet frame with address W and S. The header also contains a protocol type field that is set to a value corresponding to IP. The Ethernet frame is then broadcasted over the LAN. The server's network interface card recognizes that the frame is intended for its host, so it captures the frame and examines it. It finds the protocol type field is set to IP and therefore passes the IP packet up to the IP entity. The communication from the workstation to the server is completed. Now consider a case that a server wants to send an IP packet to PC. The PC is connected to the router via a point-to-point link that runs PPP as a data link control. and the IP addresses on either side of the link were negotiated when the link was set up. IP table at the server indicates packet should be sent to the default router because the destination is not in the server's LAN. So the IP packet is encapsulated with source address S and destination address R. The Ethernet frame is broadcasted by server's network interface card and captured by router's network interface card. Router's network interface card examines protocol type field and delivers packet to its IP layer. Its IP layer examines IP packet destination address and determines IP packet should be routed to network address 22. Router's table indicates 22 is directly connected via PPP link. IP packet is then encapsulated in PPP frame and delivered to PC. PPP at PC examines protocol type field and delivers packet to its IP layer. Routing is completed. As a summary, encapsulation is key to layering, and layers work together for routing.